Starting back up with test 3 out of the 6 paper tests on College Board. This is going to be wrapping up Module 1 of the Math, or Part 5 of 5 for Module 1 of Math for the test above. Jumping into number 24 here, these last few problems are going to be kind of the hardest, best problems on each of these practice tests. So we want to go into them really focused and with the idea of creating that kind of optimal way to solve it, right? There might be a few ways we could try 24. If I scroll down, maybe I could plug some of these functions into Desmos. Maybe I'm familiar with the parent function that's being used here. But instead of all that, let's just create this kind of generalized, optimal way to solve these types of problems, right? But let's get into it first. I see that we have a graph above. And again, I see this function here, but it's filled with way too many variables for us to get an inkling of anything yet. I see that at least the graph they showed above is going to be this f of x. So maybe we can make a connection between our graph and that function, right? Before we do that, I just want to finish it. They do tell us that they're going to be showing us g of x in our answer choices down below. And that's going to be making some sort of translation, right? We're adding 4 within our parentheses or to our x to our f of x function. So I go back up above here and I think, well, I have a graph which shows me a lot of data points, right? And then I see that we have a function with a lot of variables. Is there any way I can make a optimal connection between this graph and this function here, right? Remember, anytime we have a graph, anytime we have a depiction of our function, we can always get x and y points, right? If I just jump to a couple easy ones, I see that we have a -10, -1. So I can kind of write that over here off to the side. We have -10, -1 for my x, y. And I see a second point, this one right here, a -7, -2. So if I kind of just plug that in down below, might that get me some sort of solution here? And what I mean by that is if I take my f of x, or I can plug in a -1, and I set that equal to a over, and I see this x, or -10, plus b, right? So this would give me one equation. And then I could use my second point to get me a second equation. I can say, okay, what about -2 is equal to a over, and then my x is -7 when y is -2, and then plus b. And that might be like a system of equations I don't necessarily feel like solving right now. So I just pull up my Desmos. And I'll try to shift it down so we'll pull it up after I have all my equations typed in. And we type in our -2 is equal to, and again, for my a and b, I'm going to plug in x and y because Desmos doesn't like letters other than x and y. So I'll do -2 is equal to x divided by -7 plus y. And for my second equation, -1 is equal to x divided by -10 plus y. And now I can kind of pull it up and cover up those equations. So what this is telling us is our intersection point immediately tells me that my xy, and I'll kind of show this over here, my xy is going to be 6, 4. And I'll hide Desmos now so you can see that. So down below here, I'm showing that my xy is 6, 4, but remember I replaced my a with x and my b with y, right? So this is actually a and b. So pretty quickly there, I figured out that my f of x function is just going to be, my a is going to be 6 over x plus 4. So I feel like I just really made this problem super simple. If we know our function above is 6 over x plus 4, and they're giving us a translation, there's only 2 types of translations they're going to give us. This is going to be maybe a little bit more of the confusing type of translation where they're affecting our x. So remember, when it's inside of parentheses like this, we're going to be adding or subtracting away from our x. So if we have like an x plus 4, we are adding 4 onto that x. So it should actually translate to 6 over x plus 8. And then the other way that they're going to show translations is they're going to show it outside of parentheses. So if I kind of rewrote that above here, if they said f of x plus 4, like that, that's where you're going to see it most often. I would have gone to this equation here, and I would have just said plus 4 kind of on its own outside of the fraction, right? So when it's outside of f of x, it's going to be on its own plus 4. When it's inside the parentheses with x, we add it directly onto our x like this. I just scroll down below now, and I look at my answer choices, and it looks like it's going to match up with C. So remember, it seems like a lot happened there, but it's all about creating, that kind of like comfortable, optimal strategy. I see a graph, I get 2 points, and then I just plug those 2 points into my function they give me, right? Again, because of Desmos, I wish we could just use a and b there. That would make this much more convenient. Because of Desmos, I change those out for an x and a y. I get my 2 equations. I get my point for a and b pretty quickly, throw that back in my original function, and then I just do a very slight translation to get my g of x. This is an excellent problem to practice. I feel like just looking at this a couple times and you could master this type of give you a complicated function with a lot of variables, and then you can solve for it, right? Excellent problem there. Jumping into number 25 here, I want to think of it in a similar fashion to 24, and that I could just jump down a few different routes trying to solve this, but I want to take a step back and approach it with the optimal strategy, right? So the first thing I should notice in 25 is, in my expression, I have 2 different fractions, correct? And I look down below, and they're all 1 fraction. So I already know that the kind of overall structure of this problem is I have 2 different fractions, I want to find a common denominator, and I want to combine them, right? But there could be a little bit of a trap here, and that is, while my first fraction over here is already simplified, this second fraction might cause some of you to try to simplify it, right? And that's very normal. I almost usually advocate for, when you see these quadratics in the numerator and the denominator, try to factor them. A lot of things usually cancel out, and it makes our problem easier, right? But we also want to know when not to do that. And just to give you an example of what I was kind of saying is, when I see this one, I might immediately jump to, okay, that's factored. If I factor this, I get xy, x minus 8. And then look at that. I can cancel out my numerator, x minus 8, my denominator, x minus 8, the y, and I'd be left with just 1 over x, right? The problem with that is now if I wanted to find common denominators, right, this would be gone. It'd be 1 over x, and it would be this over x minus 8. My common denominator then would just be multiplying both sides by, this side by x, this side by x minus 8. And I look down below and I don't see any denominators that are x times x minus 8 or x squared minus 8x. So I want to try to help us, push us in the direction of avoiding these kind of routes that don't lead to a solution. And the way to do that is I'm always analyzing my answer choices too, right? My smallest denominator down below is already one of my denominators above, right? So there should be no simplifying on that side of our fraction because it's going to make it smaller and it's already the smallest one down below. So we don't want to make it smaller. So C could also be a little bit of a push in the right direction of maybe that already is my common denominator. So if I kind of refactor that, but not with the intent to cancel out, but with the intent to get common denominators, this is going to be xy times x minus 8. And then I look at my other fraction and it already has x minus 8. So all I would need on my left side here is to multiply by xy, right? So I multiply the top by xy, I multiply the denominator by xy, and my new numerator, or rather denominator, becomes xy times x minus 8. Or it looks like in all my answers, all my denominators are in expanded form. So I would do x squared y minus 8xy. And what's nice here is I don't even have to do my numerator. There would have been, I think, 4 terms up there, combining everything, combine like terms. But looking at my answer choices, this is the only one that has this as my denominator, right? So it's cool because we could maximize our efficiency on this problem by avoiding that little trap. And by also analyzing our answer choices, we can get to our answer very quickly here. I don't have to simplify my numerator. C is going to be it here. In some of the harder versions of this problem, yeah, maybe they also make B have the same denominator, and I would have to get the correct numerator, but it's not that bad. I would just distribute this, and then I would distribute this, and then I would just combine like terms, right? But still, great problem. C is going to be the answer for 25. Try to make sure to avoid those kind of pitfalls I analyzed in the beginning. And then we have our final 2 problems here, number 26 and 27. Let's see what we got. So in number 26 here, we have poll results, so maybe 2 people running for something. And it's a total of 803 voters, so I know that's going to be 803. Selected at random, were asked which candidate they would vote for in the upcoming election. According to the poll, Okay, so this is going to be a sample versus population question, right? This 803 was the sample that they analyzed, but it's the total of 6,424 people, maybe in like the county or the local town, right? According to this, by how many more votes would Angel Cruz be expected to win? All right, so not so bad. So already, what if I found out how many he's winning by, right? So if I found out how many he's winning by right now, it looks like it's going to be 483 minus 320. And just to kind of depict that, 483 minus 320 is going to equal 163. But remember, that 163 is out of 803. So with these sample populations, you're always just making proportions. So the 163 is what he's winning by out of our 803 total sample. So they want to know what he's winning by out of the total 6,424, right? So again, this proportion's just describing what he's winning by and our totals, sample versus population. So if I did that, I should cross multiply and I get 803x is equal to 163 times 6,424. And I think I can just divide that by 803, and I'll shift down a little bit for you. So if I type that in, I should be able to get my x here times 6,424 divided by 803, and I get 1,304, or B for 26. So again, not too bad. Just stay organized for these problems. When it is like sample versus population, it's always going to be comparing proportions, and you should get B for this one. Finishing up with number 27 here, I see that we have this graph, and it's going to be a circle, and they want to know what our radius is, right? So first things first, I want to open up my Desmos, and I just want to plug this function in, and maybe it'll just tell me my radius right off the bat. I see plus my y to the second plus y, and that's going to be equal to 199 over 2. And I see my circle there, right? I see that we have a very odd endpoint that's like a negative decimal and a very odd positive decimal. And I just want to remind us that if I made this a much easier example, say I got like -4 for my left number there, and I got +4 for my right number. Well, to get our radius or to get our diameter, it's always just going to be the distance that I traveled, right? So to go from that negative endpoint to my positive endpoint, or whatever my endpoints are, you almost want to make everything positive. Like distance is always going to be positive. So that would have gotten us, in this example, a total distance of 8 traveled, or a radius of 4, right? So it looks like we might have to round a little bit, because I think the decimals go on a little bit longer than that. But if I pull it back up, my right number here is going to be that, and I'll kind of take that and I'll copy it in here to kind of add to my other number. And I see this number here. And again, I'm ignoring the negative because remember our distances are always going to be positive. And it looks like I get 19.97. And I think our decimals would have gone on a little bit longer there if you graph this in your calculator. So I think that's getting us a total of 20. Let me hide Desmos. I think that's getting us a total of 20 for our diameter. And then again, if I divide this by 2, I should get 10 for our radius. So not too bad. A nice conclusion to this test. We just throw it in Desmos, get our 2 endpoints, add them together, making them both positive, and we get a radius of 10. But yeah, this is going to be part 5 of 5 for the module 1 of math for this test right here. If you want to go back through, we went over some really good problems, and I'll be starting with test 3 reading tomorrow.